in our next section, we can use something called QSP to determine whether a non-equilibrium solution will precipitate. So for example, if we're thinking about cadmium sulfate, which is the chemistry name for cadmium yellow, a yellow pigment used by Impressionist painters. We know that cadmium sulfate would dissociate into cadmium ion and sulfide ion, so this reaction is written as a KSP reaction. And so if we wanted to know if we would form a precipitate when we mixed some aqueous solutions, we could calculate QSP. Remember that QSP has the same formula as KSP. So here that would be cadmium 2 plus times sulfide 2 minus. But instead these would be non-equilibrium amounts instead of saturated equilibrium amounts. And then we can compare the QSP to the KSP. If QSP is bigger than KSP, that means we have too many of the aqueous ions compared to the solution, or compared to equilibrium, so that will result in precipitation. If QSP is less than KSP, that means we have not enough aqueous ions and more could be dissolved. And when QSP equals KSP, that means that the solution is saturated. No more can go in without precipitating, but we have the maximum dissolved, and that's equilibrium. We can calculate or determine whether a precipitate will form by comparing QSP and KSP, and like in this problem. So here, we say we mix 500 milliliters of a 0.001 molar solution of cadmium nitrate and 300 milliliters of 0.02 molar sodium sulfide. Will a precipitate form? And we're given the KSP of cadmium sulfide. So, always a good idea to start with our balanced chemical reactions. So here, the relevant chemical reaction is cadmium sulfide, solid, becomes cadmium 2 plus aqueous plus sulfide 2 minus aqueous. And so we know that we know what KSP is, but in order to evaluate whether or not this will precipitate, we need to calculate QSP. So we said before that QSP is going to be the concentration of cadmium ions times the concentration of sulfide ions, and that needs to be in the mixture, not just individually. So in order to calculate the concentration of cadmium ions, we're going to need to find the moles and the liters. So to find the number of moles of cadmium, we know that that's going to come from the moles of cadmium is going to be equal to 0.001 mole cadmium nitrate in 1 liter, times 1 mole cadmium ions for every 1 mole cadmium nitrate. Times the 0.5 liters, 500 milliliters. And so that's going to give us that the moles of cadmium are 5 times 10 to the minus 4th moles of cadmium 2 plus. And so we can figure out that that's going to be 5 times 10 to the minus 4th moles of cadmium 2 plus in the total of 0.5 liters plus 0.3 liters of the other solutions. We're going to mix those volumes, and so the concentration of cadmium ion in the mixture is going to be 6.25 times 10 to the minus 4th molar. To find the concentration of sulfide, we're going to do the same thing. So we can find the moles of sulfide in the mixture. by considering that we have 0.3 0.3 liters times 0.02 moles of sodium sulfide, it's moles, per 1 liter. And that for every 1 mole of sulfide for every 1 mole of Na2S. Okay, so if we do that, I get that we have 7.5, oh, no, I don't get that. I get that that ends up with 6 times 10 to the minus third. Times 10 to the minus third moles of sulfide ion. And so then if we put that back into our equation over here, so 6 times 10 to the minus third moles of sulfide divided by the 0.8 liters total, the mixture of the 500 and the 300, that we get that the concentration is 7.5 times 10 to the minus third molar. Okay, now to calculate, put those back into QSP, I get that QSP equals 6.25 times 10 to the minus 4 times 7.5 times 10 to the minus third molar. All right, but K's and Q's don't have units, so this comes out to be 4.7 times 10 to the minus 6. Okay, so now when we remember that KSP here is 1 times 10 to the minus 27, so QSP is quite a bit bigger than KSP. So if QSP is bigger than KSP, that means we have too many ions in solution compared to the equilibrium mixture, because the ions are the products. So that means that we will get a precipitate. So that will result in a precipitate of yellow cadmium sulfide. And this is the way that you might prepare the yellow pigment shown in this impressionist painting, by precipitating it from solution of cadmium nitrate and sodium sulfide.